For topic 4, we're going to look at exponential notation with negative bases. And before we get started, there's a couple of things from previous videos I need to remind you of. When it comes to just the signs for multiplying integers, you need to remember that if you're multiplying two integers that have the same sign, you're going to get a positive product. So whether those signs are positive or negative, if you have two of the same sign, they have a positive product. And then if you have one of each sign, so different signs, you get a negative product. We also need to remember what happens when we multiply a series of integers. So multiplying a series of integers. So we talked about this in the very last video, but I want to remind you of it again now. If you have an even number of negatives, that equals a positive product. So essentially, if you're multiplying an even number of negatives, each group of two negatives pairs up to become positive. There's no leftovers. Everything just becomes positive. However, if you have an odd number of negatives, that's going to give you a negative product. Essentially, if you're multiplying and you have an odd number of negatives, each group of two negatives pairs up, but then there's always going to be that one leftover negative that makes the whole thing negative, okay? So let's go ahead and dive into exponential notation. You should remember what exponential notation is. Remember, this is shorthand for repeated multiplication. Okay, so basically, if you're dealing with exponential notation, you're dealing with an expression of the form a to the n, where a is the base, that's the number that's being multiplied repeatedly, and n is the exponent, which indicates how many times the base is used as a factor. That's just a fancy way of saying it tells you how many times the base is multiplied by itself. Okay, and when your base, A, is negative, you have to look for two different conditions. So we have basically two situations that can arise. So let's look at the first one. So when you do have a negative base, you can have a situation where the base is in parentheses. So that would look like something like negative A to the n. Okay, that negative and that A are married together basically with those parentheses. You can't separate the negative and the A. So the negative is just as much a part of the base as the A is, okay? So essentially, the negative gets repeated right along with the A. So the negative gets repeated along with the A. So what I have written out here is the negative sign is part of the base. Those parentheses say it's so, okay? The exponent will then determine the sign on the final product. And hopefully that kind of makes sense because remember, exponential notation is shorthand for repeated multiplication. And we already know if we're multiplying a series of integers, if you have an odd number of integers that are negative, that's going to give you a positive product or a negative product. If you have an even number of integers that are negative, that's going to give you a positive product, okay? So the exponent is going to determine the sign of the final product because the exponent tells you how many times that negative is being repeated. So if we have, let me go yellow here. So if we have an even exponent, that's going to give us a positive product. So you're basically multiplying an even number of negatives, okay? Because again, the exponent tells us how many times to repeat our base. So the exponent tells us that. That's also telling us how many times we repeat our negative. Now, on the flip side, if the exponent is odd, that's going to give us a negative product. So you're multiplying an odd number of negatives. We already know that's going to give us a negative product, okay? So let's look at these examples. So for an even exponent, we look at -2. I'm right here, by the way. We look at -2 in parentheses to the fourth power. That negative and that 2 are tied together. You can't undo them. So the negative gets repeated right along with the 2. So -2 in parentheses to the fourth power is -2 times -2 times -2 times -2. Well, if you look at the first two factors, we get -2 times -2, that's just +4. If we look at the second two factors, we get -2 times -2, which is +4. And then finally, 4 times 4 gives us +16. Okay. Now for the next example down here, we have -2 to the 5th power. Here our exponent is negative. Again, that negative is in parentheses. That negative gets repeated right alongside with that 2. So this is going to be the same. -2 to the 5th is the same as -2 times -2 times -2 times -2 times -2. That's -2 as a factor 5 times. So what happens is the first two -2's multiply to become 4. The second two -2's multiply to become 4. And then you're left with that last -2 that can't pair up. So what we have here is 4 times 4, which is +16, but then that's multiplied by -2, which makes the whole thing -32. So as long as your negative is inside parentheses and you have an even exponent, you're going to get a positive product. An odd exponent gives you a negative product. So that's kind of like the first case that we could come up with. Now, the second case that we could see is dealing with a situation where your negative is not inside parentheses. So that would look like something like -a, no parentheses, to the power of n. Okay, and this is the one that probably bugs math students the most. Okay, so in this case, the negative sign is not part of the base. It's treated as a completely separate factor. So I would take this -a to the n and I would automatically think of it as -1 times a to the n. Okay, so then you figure out what a to the n is. That's always going to be positive, and then you multiply it by a -1. So no matter what your exponent is, this is always going to have a negative product. Okay, so the negative sign is not part of the base. It is treated as a separate factor. The negative sign is applied after evaluating the exponent. The result is always negative. So it doesn't matter if you have an even or an odd exponent, because you're separating that negative from the exponential notation, you're always going to get a negative product. So I've given you two examples here. We have -2 to the 3rd. Well, I'm immediately going to rewrite that as -1 times 2 to the 3rd. Well, 2 to the 3rd is just 2 as a factor 3 times, so I get -1 times 2 times 2 times 2. Well, 2 times 2 is 4, times 2 again is 8, but you have to multiply 8 by -1, which gives us a product of -8. Okay, next we have -2 to the 4th. Again, the negative is not inside parentheses, so I immediately rewrite this. I rewrite it as -1 times 2 to the 4th. Well, 2 to the 4th is just 2 times 2 times 2 times 2. So 2 to the 4th is 16, but we have to take that 2 to the 4th and multiply it by -1, which gives us -16. Okay, so when you're dealing with a negative base, the only way to get a positive product is if the negative is inside parentheses and the exponent is even. Otherwise, these are going to be negative. Okay, so let's look at example 4. The directions here just say to evaluate. Part A, I have -6 squared. First thing you want to do is say, is my negative in parentheses or not? Here, it's not. So I would automatically rewrite this as -1 times 6 squared. Well, 6 squared is just 6 times 6, so this is -1 times 6 times 6. Well, 6 times 6 is +36, but then I take that positive and I multiply it by -1. That gives me -36. Okay, so again, no parentheses, it's always going to be negative. Now let's look at part B. Part B, we have -5 in parentheses to the 3rd power. That negative and that 5 are tied together. You can't undo them. You can't treat the negative as a separate factor. So both the negative and the 5 are going to get that exponent applied to them. So this is the same thing as -5 times -5 times -5. Well, -5 times -5 is +25. But then we take that +25 and multiply it by -5 again, and that gives me -125. So again, you can see here we've got another negative product, and the reason for this negative product is the negative was in parentheses, but the exponent was odd, so it gave us a negative product. Finally, for part C, we have -3 in parentheses to the 4th power. So because the -3 is in parentheses, that negative gets repeated right alongside the 3. So this is going to be -3 times itself 4 times. Well, -3 times -3 is just +9. The second -3 times -3 is just +9. And then finally, 9 times 9 is +81. So this is the only scenario where you can get a positive product when you have a negative base, and that's when the negative is in parentheses and the exponent is even. Okay, so there you have it. That's exponential notation with negative bases. One more video and we'll be done with this worksheet.